Assalamualaikum and good day to all of you. So I will start this semester with video lesson, lecture 1, which titled Introduction to Local Area Network. So first let's look at the network component section. So we need to define, in order for us to understand network components, so we need to define the terminologies of network. So a network is a system that connects two or more independent computing devices. So the devices can consist of computers, servers, printers, or smartphone, so that they can communicate, exchange data, and also share resources like files or internet connections. So computing device, as I mentioned, can be consist of computer servers and printers, and the resources can be information, file, and also the internet connection. So the host roles in networks in every connected device is called host or end device. So for example, um, here PCs, laptops, smartphone, printers, and servers can be called as host or end device. So hosts can have a different roles. So the two main roles are clients and servers. So server is the computers that provide information to end device, such as email server, which stores and manage email messages, and then web servers, which host the websites and deliver web page to users, and file servers that stores files and that is centrally accessed by users, and can be shared between them. So a client is a device or that requests information or services from a server. So for example, when you open the website, your computer acts as a client and requests web pages from a web server. Or sometimes you will check emails and your device requests email from an email server. So the diagram illustrates the client-server model where a client will send requests through the network or internet, and the server will respond with the requested data. So in the real world example, so when a student access university e-learning portal, ULearn, so their laptops are the client while the university web server provides the website and learning materials. So it is possible to have a device to be a client and a server in a peer-to-peer network. So in a peer-to-peer network, what happened here is each device can act as both client and also the server. So device share resources directly, such as files and printers, without a dedicated server. So in the P2P network, peer-to-peer or P2P network, it is suitable for small networks because they are easy to set up, and then less complex and low cost. However, they have limitations including lower security, no centralized management, and poor scalability, and also slower performance as the network grows. For example, a small home network where computers share files and are printed directly um, will use a peer-to-peer network. And now I want you to introduce with the term end device. So originally, previously I've said that a host is also an end device. So end device is where message originates from or where it is received. So data originates with an end device, flows to the network and arrives at the end device. So in the diagram here shows communication between end device. So and device here between the two different lines. So data starts from a source end, travel through the network device. Here it's the network device and reach the destination and device. So we need to note that message can take different routes. Either they can use this path or this path across the internet network to reach the same destination. So example of a device that I have previously listed is the personal computer, PC, servers, and also mobile phone. So in the intermediary network device means that the device that interconnects and device. So if we look into this diagram, the devices, the end device in the LAN is the servers and the PC and the IP phone. But along the way, when you want to deliver the message from one LAN to the other LAN, so you need to go through the intermediary network device. So the intermediary network device is the device that interconnect and device. So examples include switch. So this is switch. So we have two types of switch, which is LAN switch and also multi-layer switch. And then wireless access point, routers, and also firewall. So management of data as it flows through a network is also the role of an intermediary device, which include regenerating and retransmit data signal, maintain information about what pathways exist in the network, and notify other device of errors and communication failures. So communication across a network is carried through a medium which allows a message to travel from source to destination. So mainly there are three types of medium: transmission medium or network media, which is the first one is metal wires within cable, which uses electrical impulses, and then the fiber optic cable that use pulses of light, and wireless transmission that use modulation of specific frequencies of electromagnetic waves. So this is the example of three different media type used for the communication across network. Next, I will explain about network topologies and type. So in the network diagrams, network representation or network topologies means a network diagram. Okay, so sometimes we call it a network diagram, but more often we call it as the network topology diagram. So the function of the diagram is to represent devices and connections in the network. So in the diagram here, in this diagram, shows three categories, which is end devices, intermediate devices, and also network media. So under end devices, we have the PCs, here the desktop computer, the laptops, printers, and also IP phone. And then on the intermediate device, we have the switches, which there are two types here, routers, and also the wired router, and also wireless router, and the firewall appliances. And next we have network media, which is wired and wireless media communication. So the important networking terms that you need to know is the NIC. NIC is the network card which used to connect a device to the network. So each of the device, the networking device or end device, will have a network card that um, identified uniquely using the NIC ID. So then we have physical port, which is the actual connection point on a device, and we will have the interface, which is the network connection used to send and receive the data. But sometimes the terms port and interface are used interchangeably, particularly when we are talking about the routers and the firewall appliances. So there are two different type of topology diagram, which is the physical topology and the logical topology. So in this part, I will only introduce you, make a brief introduction of what's the difference between physical topology and logical topology, but you will have a specific course, specific subject that will discuss on the network design later on next year. So physical topology diagram illustrate the physical location of intermediate device and cable installation. Hence, the reason why you can see here when we draw the physical topology diagram, the arrangement of the diagram is based on the location of the networking device and also the end device. So in here, for example, we can see that for server 123, web server, email server, and file server is located are located in server room. So basically, the arrangement of the placement of the networking device is based on the room, the actual area where the device is physically located. So in here you can see that the logical topology address the devices, ports, and addressing scheme of the network. So you can see here the physical topology is more on how the or where the physical device is located, and on the logical topology address more on the IP addressing scheme like the network address, the connected port um, of the devices. So for the network, we have many sizes and it is classified into four different type of network according to its size. The first one is the small home, which for the personal use, and then for SOHO is the small office, home office, where maybe in a company, a small company that have only 5 to 10 staff. So in the SOHO part, it enables computer within a home or remote office to connect to a corporate network. And then for the medium or large network, so um, it represents networks where there will be hundreds or thousands of interconnected computer, and then we have the World Wide Web that connects hundreds of millions computer across internet. So now let us look at the type of network. Mainly can be classified into two. If you see here, the representation of the size depends on the number of hosts. Number of hosts or number of devices in the network. But when we talk about the network topology and types, so basically it can be classified according to two, which is local area network and wide area network. So in the in defining the network type, we do unlike the previous one where it's defined based on the number of hosts, but here the network type is defined based on the network infrastructure that have several criteria, which is the first one is the area covered, size of the area covered, number of users connected, numbers and type of services available, and also area of responsibility. So in this diagram, it shows multiple LAN at a central office, okay, central office, branch office, and also home office. So we have three independent LANs here, okay, and all of this LAN, each of this LAN, it connects local devices such as computers, servers, and also phone within a limited area. Like for example, for this branch, it's also connected the phones within a limited area. So individually, we have three separate LANs, but these LANs are connected through wide area network represented by the cloud. So one here enable communication and resource sharing between three different LAN which are geographically separated locations. So if we look into the criteria or characteristic of LANs, they are typically faster and smaller, while one because it covers large distance, so it can connect multiple LANs together. So here, a LAN is in this slide shows the differences between LAN and WAN. So the keyword here is a LAN is a network infrastructure that spans in a small geographical areas, while a WAN is a network infrastructure that spans a wide geographical area. So this is the characteristic in the LAN, and it is administered by a single organization or individual, while WAN is typically administered by one or more service provider. So you can see the difference here that the administration for LAN is by an organization, but for the administration of one is under the responsibility of the ISPs. So in the LAN, it provides high-speed bandwidth to internet devices, but in the WAN, it typically provides slower speed links between LANs. So next, in the previous diagram, I have shown you that the one is represented by the cloud here, but the cloud that I'm talking about here is not the cloud provider, but is the internet, which is managed by the ISP. So the internet is a worldwide collection of interconnected LAN and WANs. So LANs are connected to each other using WANs. So for example, in this diagram, we have 1, 2, 3, 4, 5 LAN, and all of the LANs is interconnected to each other using the ISP. So WANs may use copper wires, fiber optic cables, and also wireless transmission. So the internet is not owned by any individual or group. So the following groups were developed to help maintain the structure of the internet. Meaning, as I have mentioned earlier on, the WAN is usually the responsibility of the ISP, which is governed by these uh, groups that help maintain structure of the internet. So the most important one is the first one is the IETF. So the IETF, or Internet Engineering Task Force, that is develops is formed to develop internet standard and protocols, internet protocols. So like for example, the TCP/IP and also the web protocol HTTP. And then we have also ICANN. This is the first two is like the most important groups or task force. Then we have the ICANN, which is the Internet Corporation for Assigned Names and Numbers, where its responsibility is to manage domain name like utem.edu.my, for example, that is domain name, and IP address allocation worldwide. And we also have the IAB, which oversees internet architecture and provide technical guidance for internet standards. So if you want to remember this, okay, so you just need to remember IETF is to create standard and protocol, ICANN is to manage domain name and address, and IAB is to oversees the internet architecture. Next, besides the LAN and WAN, we also have different type of network, which is the internet and also the extranet and also intranet. So basically, if you look at the onion layers, you can see that the outer layers is the internet or the world, and then we have the extranet, which the suppliers, customers, and collaborators, and also the intranet, which means the network is meant for the network, and the access to the resources is meant for the company only. So an intranet is a private collection of LANs and WANs internal to an organization that is meant to be accessible only to the organization members or others with authorization. So an organization might use an extranet to provide secure access to their network for individuals who work for a different organization that needs access to their data on their work. So I'll stop here, and in the next video, we'll continue with section 1.3 local area network.